Hello everyone, this is Laveti Leeladhar Manikanta, pursuing BTech second year in VVIT. I am going to discuss about test of hypothesis in statistics. In this video, I would like to cover introduction, what is a hypothesis, null and alternative hypothesis, significance level and p values, type 1 and type 2 errors, conclusion. Introduction. Welcome everyone. Today I would like to discuss one of the most important concepts in probability and statistics, hypothesis testing. As its core, hypothesis testing is all about making informed decisions based on data. It helps us to determine whether our assumptions about a population are correct or not. In this presentation, I would like to cover everything we need to know about hypothesis testing. From defining what a hypothesis is to understanding p-values and type 1 and type 2 errors. By the end of this session, we will have a solid understanding of how hypothesis testing works and how to apply it in real life situations. So sit back, relax, and let's dive into the world of hypothesis testing together. What is a hypothesis? Hypothesis is a proposed explanation of for an observation or phenomenon. It is an educated guess that can be tested through experimentation and analysis. In probability and statistics, hypotheses are used to make predictions about the relationship between variables and to test whether these predictions are supported by the data. Hypotheses plays a crucial role in scientific research because they provide a framework for testing ideas and theories. They allow researchers to make predictions about the world and to determine whether these predictions are accurate. Without hypotheses, scientific inquiry would be aimless and unproductive. Null and alternative hypothesis. In hypothesis testing, the null hypothesis is a statement that there is no significant difference between two populations or variables. The alternative hypothesis is the opposite of the null hypothesis and suggests that there is a significant difference between the two populations or variables. For example, let's say we want to test whether a new drug is effective in treating a certain condition. The null hypothesis would be that the drug has no effect, while alternative hypothesis would be that the drug does have an effect. To formulate a good hypothesis, it is important to be clear and specific about what we are testing and how we will be measure the results. Significance level and p-values. Significance level is a term used in hypothesis testing to determine the likelihood of rejecting a null hypothesis. It is also known as alpha and it's usually set at 0.05 or 0.01. A p-value, on the other hand, is the probability that the observed results are due to chance alone. To interpret the results of hypothesis testing, it is important to compare the p-value to the significance level. If the p-value is less than or equal to the significance level, then the null hypothesis is rejected. If the p-value is greater than the significance level, then the null hypothesis cannot be rejected. Type 1 and type 2 errors. Type 1 and type 2 errors are two types of mistakes that one can occur in hypothesis testing. A type 1 occurs when a true null hypothesis is rejected, while a type 2 occurs when a false null hypothesis is not rejected. In other words, a type 1 error is a false positive, while a type 2 error is a false negative. For example, if you reject the null hypothesis that a coin is fair when it actually is, we have made a type 1 error. If we fail to reject the null hypothesis that a coin is fair when it is not, we have made a type 2 error. To minimize the risk of making these errors, it is important to choose an appropriate significance level, conduct a power analysis to determine the sample size needed for the study, and use reliable statistic methods. It's also important to clearly define the null and alternative hypotheses and to report all relevant statistics and confidence intervals. By taking these steps, researchers can ensure that their results are accurate and reliable. Conclusion. In conclusion, hypothesis testing is an important tool in probability and statistics that allows us to make informed decisions based on data. By formulating clear and testable hypotheses, we are setting appropriate significance levels and interrupting p-values correctly. We can minimize the risk of making type 1 and type 2 errors and draw valid conclusions for our experiments. When applying hypothesis testing in real life situations, it's important to keep in mind the context and limitations of the data. Always be aware of the potential confounding factors and sources of bias, and use appropriate statistical methods to account for them. Additionally, consider the practical implications methods to account for them. Additionally, consider the practical implications of your results and communicate them clearly and effectively to stakeholders.